Hello students, I'll be teaching you chemistry, especially class 12 chemistry. So today we'll be discussing the chapter Haloalkanes and Haloarenes. So we know what is an haloalkane. So example of an haloalkane is CH3Cl. So here the halogen, which is chlorine, it is attached to sp3 hybridized carbon atom. So it is an haloalkane. And example of an haloarene is so here halogen is attached to a sp2 carbon of a aryl group. So it is an haloarene. So we know the simple examples of haloalkane and haloarene. So today we will be discussing about SN1 and SN2 reactions, basically substitution nucleophilic reactions. So we'll be discussing about substitution nucleophilic reaction. So basically, in this reaction, leaving group will be replaced by an electron-rich species, which is a nucleophile. We represent nucleophile with Nu minus. So it will be having a negative charge. So it's an electron-rich species. So it is a nucleus-loving species. So it will have an attraction towards a positive center. So here, nucleophilic substitution reaction, there are two types, basically SN1 and SN2. SN1 SN2. So now we'll be discussing about SN1 reactions. So SN1 is substitution nucleophilic unimolecular reaction. So let's first look into one example and then we will explain. So in this reaction you can see a tertiary butyl bromide. So this is a tertiary carbon. I hope you know what is a tertiary carbon. Basically, when a halogen, as we are discussing about halides, we have primary alkyl halide, secondary alkyl halide, tertiary alkyl halide. So when a halide, it can be bromine, chlorine, iodine, anything. So when this halide is attached to a carbon, this carbon is attached to three other carbon atoms. Then it is a tertiary. If it is attached, this is a tertiary carbon. And if that halide is attached to carbon, this carbon in turn is attached to two other carbon atoms. The rest will be hydrogens. Okay, then it is a secondary halide. So in this case, you can see that the halide is attached to a carbon. This carbon in turn is attached to three other carbons. So this is a tertiary butyl halide. So it reacts with OH minus to get tertiary alcohol. So this is a simple example of an SN1 reaction. So SN1 reaction, as I said you, it is a unimolecular reaction. So it follows first order kinetics. First order kinetics. So the rate of the reaction, it depends on the concentration of the alkyl halide. So since it depends only on the concentration of the alkyl halide, it is called the unimolecular reaction. That is, it follows first order kinetics. So you can represent rate as rate equal to K So this is how you represent the rate equation. Rate equal to rate constant there. So it depends on the concentration of alkyl halide. So it is called so it is a first order kinetics. So that is the reason you see it as a unimolecular reaction. So but this reaction, it follows two steps. First step is the formation of a carbocation, and second is the attack of the nucleophile onto the carbocation. So moving on to the step 1. So first step is the formation of the carbocation. So here you can see that CH3 thrice C, CBr. So this is the step 1, that is formation of carbocation. So this is a slow step, and this is a rate determining step. Okay, then you have the step 2. Step 2 is a reaction of nucleophile on reaction of nucleophile. Basically, it is the attack of nucleophile on carbocation. Attack of nucleophile. Attack of nucleophile on carbocation. So basically, it will be like this is a carbocation. Plus OH minus. So here, now we discussed SN1 reaction, it's a unimolecular reaction, first order kinetics. Then the rate depends only on the concentration of the alkyl halide. And here we said the step 1 is the formation of carbocation. So here you can see carbocation. Carbocation is a species where the carbon contains a positive charge. So that is a carbocation. So here you can see that CBr, that is carbon-bromine bond. There is a cleavage of carbon-bromine bond to form this carbocation. So this is a rate determining step. It is a slow step. Then second one is attack of nucleophile and carbocation. So here this is the nucleophile, which minus is the nucleophile. So this is an electron-rich species. So it will have a tendency to attack to the positive center. So it will be attacking on this positive center to form the product. Okay. So here you can see that there is a formation of carbocation. So the reactions where carbocation is stabilized. Those reactions, that is reaction which a carbocation will be stabilized. In that case, SN1 reactivity will be more. So the rate of reactivity of an SN1 reaction. So reactivity order of SN1 reaction. Reactivity will be like tertiary carbocation, then secondary carbocation, then primary carbocation, then methyl halide. this will be reacted. The reason is tertiary carbocation will be stabilized. Here you know that there is a plus I effect. So due to this reason, this carbon will be more stabilized. There are 3 electron donating groups. So this carbocation will be more stable. So that is the reason tertiary alkyl halides will be more prone to SN1 reactions. Okay, and then there is one more thing, that is benzylic and allylic halides. They undergo SN1 reactions faster. They have a higher reactivity. The reason is benzylic halide. See, this is a benzylic halide. This is a benzylic halide. Okay, so when it undergoes SN1 reaction, it will form a benzylic carbocation, which will be like so. Here you can see that positive charge is on this carbon atom. So and this benzylic carbocation is stabilized through resonance. Here you can see that this positive charge can come over this side, and then it will form in this way. That is CH2. Here you get the positive charge. There is no double bond over here. Okay, and then it will come to this side to form again. It can come to this side, then forms and then again forms a structure. So here you can see that benzylic carbocation. Benzylic carbocation. Benzylic carbocation is resonance stabilized, so it is more prone to SN1 reaction because reactivity will be high for benzylic carbocation, showing SN1 reactions. Okay, and then one more thing is allylic carbocation has higher reactivity towards SN1 reaction. Allylic carbocation, for example, this is double bond. Okay, so here this is a allylic halide, allylic chloride. Okay, so when this undergoes SN1 reaction, basically you get a positive charge over here, right? The chlorine will go and then you get a positive charge on this carbon. And here you can see that this positive charge can be resonance stabilized, like can come over this side to form CH2, CH, double bond CH2. So here you get a positive charge. So here you can see resonance stabilization. So this is the reason why benzylic carbocation and allylic carbocation has higher reactivity towards SN1 reactions. So that's it with SN1 reactions. Next we move on to SN2 reactions. So now we will be discussing about substitution, nucleophilic, bimolecular reaction. That is the SN2 reaction. So first let's look at the reaction. So here in this reaction you can see this is a primary alkyl halide. So it reacts with, so here you can see that it is a primary alkyl halide. It reacts with OH minus to give ethanol and chloride. So here it is a bimolecular reaction. I have told you it is 2 bimolecular. That is second order kinetics. So it follows second order kinetics. So when you write the rate, it will be depending on the concentration of the alkyl halide as well as concentration of the nucleophile. So it will depending on the concentration of both alkyl halide as well as the nucleophile. So that is the reason it is called bimolecular and follows second order kinetics. Okay, so okay, this is how you write the rate expression. We will be be dealing with all this in chemical kinetics chapter. Okay, so right now you just have to know this is how it is written. And then let's move into the mechanism. So this is a reaction. Here you can see OH minus is a nucleophile and it attacks this carbon. And then the chlorine will be moving from the other side. So here OH minus is attacking from the back side and the chlorine is leaving from the front side. Okay, so it has a transition state. This is called a transition state. This is a transition state. And here you can see there is a bond dissociation taking place. Bond association. Bond association. This is bond dissociation. So since these two steps takes place in a single step, it is called a concerted reaction. Okay, so here the OH minus is attacking the carbon from the back side and the chlorine leaves from the front side. Okay, and so there is a transition state in which carbon OH bond formation takes place and carbon chlorine bond dissociation takes place. Okay, so this is a transition state, and this step, that is attack from the back side and leaving from the front side, takes place in a single step. So that is the reason we call it as a concerted reaction, and you get the product. Okay, and here there is inversion of configuration. So in SN2 reaction we say that there is an inversion of configuration. In SN1 reaction we say there is a racemic mixture is found, and in SN2 we say there is inversion of configuration. So we will discuss in detail the next. Inversion of configuration. We call it as Walden inversion. Walden inversion. You can also see in some books as Walden inversion. Basically, inversion of configuration is that, see, earlier chlorine was in the front side, okay, and then OH attacked from the back side. So in the product you can see OH in the back side. So there is inversion of configuration. Just like when an umbrella moves inside out in strong wind. So that is how the configuration has changed. So that is the reason we call it as Walden inversion. Configuration is basically how the atoms are attached to atoms attached to a central carbon, especially the spatial arrangement of atoms. Basically, you can see this is a carbon. Here you have hydrogens. Okay. So now this is the central atom. Here it is carbon. So this carbon is attached to these atoms. So in some case, you have the wedge representation. This is a wedge representation, this is a dash representation. So it shows the spatial arrangement of atoms. So configuration is basically how the atoms are arranged spatially to the central carbon. So here there is an inversion of configuration. Inversion of configuration in case of SN2 reaction. SN1 it was a racemic mixture. Okay. And here one more thing. See here. This dotted lines represent that the hydrogen is present in the back side. Back side in the sense back of the bond. And here this hydrogen is present in this front. So wedge usually wedge means it is protruding outwards like this, and dash means it is below, not below, that is below the wall, the other side. Okay, so this is the representation. So that's it.